This video is going to be about setting up CyberRange traffic, and we're going to go into some detail on exfiltration. So the basic idea is someone has deposited malware onto a device that's on the network, and in this case in the CyberRange. And then that malware is going to be sending data back out to an external server that's somewhere in the world, somewhere on the internet, in another part of the world. And so the blue team is part of what they are trying to do is figure out, is to see this. They don't know it's happening. It's one of many attacks that could happen. But the AppSim, of course, on breaking point is going to be generating a massive haystack, a massive amount of traffic that is simulated real traffic that they would expect to see on a network. So they're trying to sift through all that, trying to find something out of the ordinary, an anomaly. And this would be one of those anomalies. So first we'll take a look at the setup for the exfil. We'll look at the network neighborhood in a minute. Now, this is a client sim. That means I can pick a single superflow. Fact is, I can run client sim and app sim are very similar. I can send traffic from the server to the laptop, to the client, excuse me, or vice versa. We normally think of client sims as going from here to here, but it can go back in the other direction. The client sim can run two-way traffic if I wanted to. If I selected that kind of a superflow. But in this case, what I have is a superflow, a client sim superflow, but I've set it up so that in this, the client sim is in the server position. The client is in this server position, and then the server out on the internet somewhere is in the client position. Really, it doesn't matter, but it's got to match however you set up this superflow. In the superflow, it's actually the server that sends all the traffic. Before we look at it, let's go through here. Minimum data rate, everything's low. I call it exfiltration, quiet and slow. So this is supposed to be hard to detect. And one of the things that makes it hard to detect is a low traffic rate compared to the haystack, the massive amount of AppSim traffic being generated by the breaking point. So if we come through here and look, one of the things I've set here is target minimum simultaneous flows is 1, and minimum super flows per second is 1. So what that actually means is I'm going to be sending, I mean, you'll see it in the PCAP file in a minute, we're actually sending 1 packet every second. And that's a pretty low data rate right there. And makes it pretty hard for a blue team defending their network to realize that this traffic is out there. Now the other change that I make most of the time with traffic I'm creating for CyberRange, if this is representative of attack traffic, then I might set retry count to 0 instead of 3. Instead of getting 4 copies of each packet, I just want 1 packet, 1 copy of it going out. Now let's take a quick look at the superflow itself. So I've chosen, I chose streaming media, RTSP, as my exfiltration medium. I mean, you can send HTTP packets or whatever you want to send, but I kind of decided to use streaming media. And right here you see. Now, RTSP gets used all over the internet. It actually is streaming video, streaming audio. Lots of websites use it. But you can, within RTSP, you can just send files. You don't have to stream a packet at a time, your audio or the video that you're looking at. You can send a file. That's part of it. So what I'm doing here is within these packets, I'm sending a JPEG file, and this was built into Breaking Point, the Green Hornet JPEG file. But from a CyberRange point of view, we could put actual interesting looking information in this. For example, schematics or some sort of recorded conversation, or we could put I mean anything you want, something that that looks like privileged communications, I'll call it. Whatever you want to put in this, or whatever your customer wants to put in this, that's kind of a handy. This is a handy way to do it. So, but if I go back to the top real quick, my source is a server. This is the only thing. This is all I'm using of the RTSP Superflow, and so my server is sending this traffic. And if we go back to our client sim, sure enough, infected client, infected laptop rather, is the server, and this is the one sending the traffic. So what does all this really mean? Well, so check this again, exFils server, and then infected laptop. Now I'm going to go and see who those actually are. We'll look in the network neighborhood, and this is all internal on my laptop. In a real CyberRange, you would actually have some external hosts, and some of those would be clients, some of them would be servers, and some of the haystack you're generating would be traffic from one machine to another on this network. So as you might imagine, you want switches to be set to flood or be set to promiscuous so that everybody sees the traffic. We want to be able to spoof traffic that appears to be generated by something that's on that network, like an infected laptop. And so take a look at, here's an infected laptop. This was in that exFil client sim, and then exFils server was the other one, and this is so you see this is the address way off in the internet, some other country or some other part of this country, whatever internet, whatever IP range you want to use or IP address. And then for exFiltration, there's one server out there that's going to receive this traffic, and there's one machine that's going to be generating the exfiltrated data. Its address is 168.1.18. Now further up, I have what I call host laptop. This is 10 hosts that I'm simulating, or could simulate if I was using it. 168.1.15, and there's 10 of them, so that's 15 through 24. .15 through .24. Those are the addresses that are being used by these. And if this were, say, a CyberRange, then these would probably be real devices or VMs on the CyberRange. So this entry would probably be an external host entry, as in endpoint IPv4 external hosts. Now I'm not going to add them here because I don't have these. I don't have these external hosts, and so. But on a real CyberRange, that's probably where those IP addresses would be. But then again, maybe not. If I put the addresses here and this is an overlap. 15.18 is one of these addresses, and it's also down here as infected laptop. So which we can do that, and we can generate traffic for, I could generate background traffic on the network that has these 10 devices talking to each other, sending traffic to each other. Now, what's really happening is we're just sending traffic out with source and destination pairs that match these addresses. But from the point of view of a blue team looking and watching traffic, it looks like to them that traffic's originating at those IP addresses and going back to those same IP addresses or that same group of IP addresses. So it's going to look like internal traffic to them, internal to their network. And laptops obviously would not, typically they're peers, so they're not going to be talking to each other, but you get the general ideas. You generate traffic on the CyberRange that is internal to the CyberRange. You can do that by spoofing these addresses that might be of real devices that are on the CyberRange. This could also be a real device on the CyberRange, but if they're looking closely, what they'll see is once a second, they'll see this packet go by that comes from one of their own devices, but goes out to this server out in the middle of who knows where. So let's take a look. And let's see. Well, I had it. There it is. So there's my infected laptop over and over, and there is the server off in some remote region. And here you see that we generate 1 packet per second. So we're sending data across 1 packet per second. And like I said, you could use RTSP, or you could use anything that allows you to send information from point A to point B. You can use that protocol. But this is what the PCAP looks like, obviously filtered for my particular IP address. There's all sorts of background traffic from my VMs on here right now. But this is the traffic we get. So that's data exfiltration, data information stolen from a network in the CyberRange, stolen from a device in the CyberRange, and sent out to some remote server, and it's out there. It's there once a second for the blue team to discover. And next, I'm going to talk through an Nmap sort of scan of the network, and we'll set that up.